So here, which function best models the data? First, what I would do is draw in a line of best fit. Now here I notice if I draw a line here, it kind of goes through the middle of the points. So my y-intercept, b, equals 2. And then my slope, we go up 1 over 1. So m equals 1. So this, my equation would be y equals 1x plus 2, or that's just f of x would be x plus 2. So now, if I were to model this data, and I draw a line here, line of best fit, and I look at what would best model the data, it's a linear function. So here, Micah gathered data on marriage rates and found the line of best fit to be 0.1x plus 45. So what does the slope mean? So here, if we're looking at the marriage rate, the initial marriage rate is 45%. So that doesn't tell us about the slope. That's the y-intercept. So here, the marriage rates are decreasing. Well, it's 0.1. So and then this 0.1 would be every time you increase x by 1, the marriage rate would increase by 0.01. So this is actually true. Every increase of 1 in x increases the y value by 0.01. So here, which function has the largest range with the domain of 2? So if x is 2, I'm assuming this is saying what's the largest y value. So if we just evaluate this, y here would be 2 plus 2, which is 4. Evaluating this function, we would go 5 times 2 to the second, or that means 5 times 4, which is 20. Then here we would have negative 2 times 2 squared minus 2 plus 3. So here, 2 squared, it would be negative 2 times 4 minus 2 plus 3. Or that's negative 8 minus 2 plus 3. So negative 10 plus 3 is negative 7. So in looking at the function that has the largest range value at 2, or the largest value, it would be b. So here, the largest range, if x is negative 2, so negative 2 plus 2 here is 0. And then here, 5 times 2 to the negative 2. And you can evaluate with a calculator. So 5 times 2 to the negative 2 is 1.25. Then here we would go negative 2 times in here negative 2 squared minus 2 plus 3. So here negative 2 times negative 2 squared minus 2 plus 3 is negative 7. So in looking at which value is the largest, it would be the 1.25. So moving on to here, which function increases fastest for a domain value for all real numbers greater than 5? Well, in looking at that, a exponential function is going to increase faster for all of them. So the quadratic function would not, this would, and it's going to be this one. I can show you visually on a graph. So if we put all three functions in, we can put in y equals x plus 2. The second one would be, let me clear that out and go 5 times 2 to the x. Then here we have negative 2 x squared for a quadratic minus x plus 3. And I'm just going to graph them. And if you notice, which one is the highest after 5? Well, this one's already way higher. So I can change my window and change the y max. So let's say 1,000. Then look at the graph. And after 5, the value that is the highest is the red graph or the exponential graph. So now here, what function best describes a set of ordered pair? So if we go 0, 3 to 1, 7 to 2 to 11, and if you notice here, I notice that we go, the y value goes up 4, then this goes up 4, and we keep going up 4. So since I'm increasing by 4, my slope here is going to be 4, and it's going to be a linear function. And initially, the y value is at 3, so b equals 3. So a linear function, remember, is y equals mx plus b. And in this situation, it would be y equals 4x plus 3. So in looking here, we go from 1 to 4 to 16 to 64. I am multiplying by 4. So this means it's going to be exponential. My initial value is 1, so a equals 1. My growth factor, we're multiplying by 4. So this would be y equals a times b to the x. And in this situation, it would be 1 times 4 to the x. And if we're just multiplying by 1, we would just write this as y equals 4 to the x. So here, if I go from 0 to 1, and I'm going to 2 to 3, then to 5, and then 8, and then the 12. Here, I add 1, and then I added 2, and then I added 3. And since I'm not multiplying to get to the next number, and I'm not subtracting, this is going to be a quadratic function. So what I can do now is look at, well, what's happening? So if I make a table here, we have 0, 2, 1, 3, 2, 5, 3, 8. And just try to figure out, well, what's happening? Well, I'm going to, let's say, draw a picture. So make a step function. So step 0, we have 2. Step 1, we have 3. Step 2, we have 5. And then step 3, we have 8. And then what I'm going to do is look for squares. So this is step 0, 1, 2, and 3. And then I'm noticing here in step 1, I have 1 squared. In step 2, I have 2 squared. And then in step 3, I'm just missing some pieces. So I'm just going to keep working here and persisting to try to find a pattern to model the data. So one thing that I'm noticing is I could just double these. So if that were the original. And I'm looking at, well, could I draw them and make a square there? So what we can do here is we know it's going to be a quadratic function. So what I'm going to do is use quadratic regression. So we have 1, 2, 3, 4. And for the y values, we have 3, 5, 8, and 12. So what I'm going to do now is just go into my list here. Just go to math or stat, and then I'm going to edit. And then for list 1, I'm going to put 1, 2, 3, 4. List 2, 3, 5, 8, and 12. And then what I can do now is quit out of that, press stat, calc, and I'm going to go to quadratic regression here. And then my x list is list 1, my y list is list 2. And calculate that. And this tells me my coefficients. So here, this would be y equals 0.5 x squared plus 0.5 x and then plus 2. So now here to look at this function, what type of function is this? Well, if you notice, this here is called a step function because it looks like steps. Here we have two different lines that are joined. This is called a piecewise function because on the domain from -4 to 1, this has one piece. And then here from 1 to 3, for x, we have another piece. Here, when it's a v, this is called an absolute value function. And then here, this again is a piecewise function. So we have different pieces here, a cubic function and a quadratic function.